My name is Zulkarnaini Abdullah. I'm a senior lecturer in the Department of Industrial Refrigeration and Air Conditioning, UniKL, Malaysia Front Institute. I teach few subjects in the Bachelor of Engineering Technology Honours in Industrial Refrigeration and Air Conditioning, or IRAC. And there is one subject named Air Distribution and Secondary Fluids. The subject code is FCV 41003, which carry 3 credit hours for Year 4 Semester 7 students who have equipped themselves with the fundamentals and formulas of HVAC before. The subject is an intermediate course in fluid dynamics aimed at providing students with the fundamental concept of fluid flow, which form the foundation for their study in later years. These concepts are essential since the student will encounter this component in any air conditioning system in their studies at work and at home. Students will be evaluated with written tests, assignments, and final exam at the end of the semester. The subject includes theory and tutorial sessions. Students will have a collaborative learning in classrooms and works as a team during lab sessions, assignment, and tutorial sessions. In the previous semester, students have learned to design an air duct that distributed air around a room in a building using simple calculation and using ductilities. Continuously with this subject, there are 3 major outcomes that are expected from the students to familiarize with at the end of the course. The first outcome that the student will learn is on how to create a balance of a fluid flow in a duct using generalized Bernoulli equations. In this topic, students will be taught to measure the air flow and its distribution in duct using given equation. The Blasius and Colebrook equation are applied in calculating the pressure drop of a duct. The second outcome is to determine the performance and sizing the fan using Rato coefficient and the fan laws. Based on the fan technology, students will explore the various types of fan and analyze the characteristic of the manufacturer. Students will then compare the ideal coefficient to the selected fan model. The third outcome is to evaluate the properties of a secondary fluid and the performance of a thermal storage unit. In this topic, students will measure the required thermal energy storage unit by calculating the storage and de-storage requirement of a building. This includes understanding of secondary fluid properties.